Hello everyone, in this video we'll be covering solution for question 9 of our endsem. So let's see the first part of it. Which state that obtain basic logic gate from neural networks, summarize them in table with number of neurons, activation function and backpropagation in neural networks. So let's see. A single layer perception, the step or sigmoid activation can implement linearly separate logic gates like AND and OR. Example weights and biases using step activation. AND gate with input x1 x2, neuron output 1 if this L0, choose w1 equals to 1, w2 equals to 1, b equals to minus 1 to only 1 comma 1 gives output 1. OR gate, choose w1 equals to 1, w2 equals to 1, b equals to minus 0.5 to any input with at least 1 gives output 1. NAND gate, use negative weights of AND or negate its output. XOR is not linearly separable and requires a multi-layer network. Hidden layer with no two neurons implementing intermediate function. Example NAND and OR. Output neuron combining them. Example AND. So summary table for AND and OR, one layer, one neuron per gate. Step or sigmoid. And the perception rule or gradient descent. For NAND, one layer, one neuron, step or sigmoid again, and perception rule or gradient descent. And for XOR, two layers greater than equals to two hidden neurons plus one out, and this sigmoid or slash RELU, and backprop required to train weights. Now let's see B part of this question, which states that compares CNN, RNN, GAN, and transfer learning in terms of architecture and its application. So let's see first CNN. Its architecture is multiple convolutional layer with learnable filters, followed by pooling and fully connected layers. Its specialty is exploit spatial locality and weight sharing, good at capturing local patterns in images and grids. Its application is image classification, object detection, medical imaging, video analysis, etc. And RNS, its architecture is neurons have recurrent connections, hidden state at time t, depends on input at t and hidden state at t minus 1. Variants include LSTM and GRE. Its specialty is model sequentially and temporal dependencies. Applications, language modeling, machine translation, speech recognition, time series forecasting, etc. Now let's see GAN and transfer learning. GNN in architecture is two network generator G and discriminator D, trained in opposition G. G tries to produce a realistic fake sample, D tries to distinguish real from fake. Its application is image generation, image to image translation, data augmentation, super resolution, etc. In transfer learning, it uses a model trained on large source stars, example ImageNet CNN, as a starting point for a related target task. We keep most layers and fine-tune some layers on smaller labeled data. Advantages: reducing training time and data requirement, often improves performance when labeled data are scarce. Applications: fine-tuning pre-trained vision or language model for specific domains, like medical images, sentiment analysis, domain-specific text classification, etc. So this is it for question B. And with this question, the solutions for all the parts and all the question of endsem are completed. Thank you.